For each situation, create a hanger diagram, tape diagram, and equation, then show how to determine the missing value, which is the solution, using each representation. Alex is saving money to buy a new bicycle that costs $150. He already has $30 saved up. He plans to save money for 6 weeks. So we know how much he is trying to save. That's our $150. So that is the total that our tape diagram should equal. We're trying to figure out how long until he gets to his how much does he have to save to get to his 150? We know he already has $30 saved up. So I'm gonna put that within this 150, he has 30 of it. And then I also know that he is saving money for 6 weeks. So I have to represent those weeks, but I don't know how much he is saving, so I'm representing them using X. I'm gonna break my tape diagram into those sections. So I have a section of 30 and then I have 6 sections with X. Working backwards, since he already has $30 of the 150, I know that the remaining amount he has to save is 150 minus 30, which means all of these X's are equal to 120. So I have 6 X's equal to 120. And to find out what each of them is, that 120 is being broken up into 6 pieces. So X is 120 divided by 6, which means X is 20. Now when we go into an equation, we have to take all those parts of the tape diagram and write it as an equation. The inside of my tape diagram is 30 and 6X. And to show that both are happening, I'm going to put a plus sign there, is equal to the total of 150. I can look at the first step. I figured out that 6X was equal to 120. To show that algebraically, I would show that I took away the 30 from the left side of the equation and I took away 30 from the total. So 30 minus 30, they actually cancel each other out, and 100 minus 30 is how we got to 120. Then once I knew that 6X's was equal to 120, I divided that into the 6 parts, leaving me with X equals 20. To show that on my equation, I would show that I've taken the 6 X's and I've divided it by 6, leaving me with a single X, and I've taken the total and also divided it by 6, leaving me with 20. Because of the space I have here, the hanger diagram, I am okay that you just draw the hanger diagram to represent it. So I had 1, 2, 3, 4, 5, 6 X's and 30 on one side, and then the other side was our total of 150. So I'm going to have a bar here of 150. I'm going to use circles to show X, and then I'll put a square around 30. So I would use those same steps where I take away the 30 from that total and then divide it by 6 as I did in the other parts. Betty's Bakery has 7 trays of cupcakes for an order. They realized that the original count was wrong and added 3 cupcakes to each tray. The order had a total of 168 cupcakes. So I know that they have 7 trays of cupcakes, but I don't actually know what's on each tray of cupcakes. So that original amount is what we do not know. Since there are 7 trays, we know that those should all be the same. So I'm gonna end up with 7 groups. So 1, 2, 3, 4, 5, 6, 7. The original count was wrong. So I'm gonna underline original count. That's our unknown. So X is the original. So all of them started with an amount of cupcakes, which is our X. And then they had to add 3 cupcakes to each tray. So I'm gonna put a +3 in each group. And altogether, the order had 168 cupcakes, so that's our total. So in a problem like this, I see that all of these are the same group, so I can take 168, our total, and divide it by the 7 trays, which would mean each of my trays had 24 cupcakes on it at the end. So I'm going to put 24 above each section, which means that X and 3 is equal to 24. And since I am adding 3 to that unknown, what we started with had to be less than 24, so x is going to be 24 minus 3, which they started with 21 cupcakes. In an equation, I would show that I have groups, which we've been using parentheses to show what our groups are. In this problem, we had 7 groups, or 7 trays of x, and then we added 3 to each of them, and that original total, or what we had all together, was 168. So the step that I got to help me figure this out was that x plus 3, or every x plus 3, was equal to 24. And we got there by dividing both sides by 7. Then we figured out that x was 21, and we knew that because we took away 3 on the left side of the equation, which cancels out to 0, and we take away 3 from 24, so 24 minus 3 means x is 21. So same as what we got when we did the tape diagram. And then again, I'm just gonna draw the hanger here, but you can look at both of these examples as steps to actually find the value. So we have 168 as our total, so that's one side of our hanger, and then the other side is going to be 7 groups of x plus 3. So x and 3, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. And you can put shapes around these. I'm just going to make them all their own little pods.